So Millis is a counter that starts counting the time from the moment Arduino starts. So let's write 60% for an LED. So this says map 60, which is from 0 to 100, to a value which is from 0 to 255. 10%. So this is now 8%. And let's have a look at the switch and case. This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. Welcome to Arduino course by Robojax. Now let's learn about Millis. In this tutorial we are going to learn how to use the Millis or millisecond in Arduino programming. So what is Millis and why we have to use it? First, Millis is an internal function from Arduino that calculates the time in milliseconds from the starting point when Arduino program runs. As soon as you power up the Arduino, the Millis will start with 0 and it goes up in milliseconds. For 1 second you will read 1000, and for 5 seconds you will read 5000, and so forth. But it can be accessed throughout the code at any point. For example, you can record start of a point and then stop of a point. At any moment, for example, let's say somebody press a push button or temperature increases or something is detected, you can say, I'm counting from this point until some other event happens or until you want it. For example, a push button is pressed and in 5 seconds you want to do something. From the time the push button is pressed, you can save the Millis in a variable and then you can check it continuously until you see when it is 5000 milliseconds or 5 seconds, then you can take an action. Many times people will need to use delay, the function delay with 5000 milliseconds, and it will be 5 seconds delay. But the problem with the delay is that it will halt all program. Everything that you have, everything will be waited until the delay passes, then they will continue. But with Millis, it will not interfere with any other features that you have, and you can calculate the time, and the rest of the program or components that are connected to Arduino, they all function normally. Now let me show you practically on Arduino. And here I've defined the serial monitor with 9600 baud, so it can display the value on the screen for me, and this is just a text, and I'm waiting for 2 seconds here using the delay. To use Millis, we type Millis, M-I-L-L-I-S, and open and close parentheses. This means it's a function with an Arduino. But this is just a value at the moment that Arduino starts, and it will increment every millisecond. Now let me print it for you first. I've written this code like this using serial println. Println means new line, so it will print the Millis value and will create a new line. The speed of how fast this is printed now depends on serial monitor, because it has to read the value from Arduino and bring it back on the screen. For that reason, this will delay it, but we will see some value, and I did not put any delay here, so you will constantly see the values. And I'm going to stop it so we can review it. I'm opening the serial monitor from here, but you can click on Tools, Serial Monitor, or you can use the Control Shift and M to open it. This is 2 seconds, and that's it. It will start automatically. Let me stop it, and here, as you can see, the scroll bar is going crazy. It's continuously printing. Let's see here. Automatically, it was 2 seconds here, remember? I put that 2 seconds delay, the program starts running, and after 2 seconds it prints 1999 because 0 is also millisecond. The first millisecond is 0 and then 1 and 2. And after that it prints it very quickly because the serial monitor prints it very fast, and slowly you see here 8, and this has been printed a little late, 4 milliseconds late, and then from 4, and this is longer, and from here to here 6 milliseconds. So you got the idea that this is the time from the beginning. Now it's 52 seconds, and it continuously will print. If I leave the scroll on, you will see that it's 60 seconds, 1 minute. So continuously it prints the value. You got the idea. The value for the Millis is unsigned long. That's very important because if you try to compare it with an integer, you will get error according to the Arduino website. So I'm defining an event. Let's say you want to take some action after 5 seconds. We're defining it as a type long, and we put unsigned, which means it doesn't have negative or positive, so it has no sign. Unsigned long event, this is our variable, and the value for that is 5,000 milliseconds or 5 seconds. And here we check from the start it as 0, and it increases until it reaches equal or greater than event. If it is bigger than 5,000, this will be printed. And let me open, and as you can see, these are milliseconds, 1 second, 2, and as you can see it shows event occurred. I'm disconnecting it from USB, and let's see at 5,000, 4,995, and here this occurred when it was 5,000, and as you can see next is 5,016, and forever it will be. So this is one way that you can remember, and the beauty of this one is that you can do any other tasks that are within the loop. They will continuously operate, and this will not interfere with them, and yet you can detect the time. If we do not use the Millis, then our option would be to have delay. For example, you want to take some action, you can say delay 5,000, and then serial print like this, and you don't have this one. This will also be printed only when 5,000 milliseconds passes. But the problem for this is until this time passes, the program will stop here and stuck here. All the code, whatever action that you have below this in this area, will not be executed. So delay is not a good option if you're working with time and there are other tasks involved. If you don't have anything else to do and the whole code is waiting for this, then it will be very simple and it will be reasonable to use delay. But in many applications, this will not work and it will be problematic. So we will use Millis. This was one example. And here I've connected this push button which has 2 pins like this. The left pin is connected to the ground of Arduino. Here we have a ground, and the right pin is connected to pin 2. And here is an example for the push button. First I've defined using pin mode, pin 2 as an input, and I also put underscore pull up. This will eliminate usage of a resistor. I have a separate video explaining that. The link will be provided below the video. And here this pin is now ready without a resistor. It accepts when you push the push button, it will be detected. And now the rest of the code is the same. I have added this line, digital read 2. So this is reading pin 2's status, either pressed or not pressed. Remember, this input pull up means it is pulling up the pin 2, this pin 2 with a resistor to positive. So it constantly will have 5 volts from this pin 2 to the Arduino. So Arduino is reading always high, and we read it and we store the value of whatever is the result into the PB or push button as an integer, So if it is high, it will be 1. If it is low, it will be 0. When the push button is pressed, it will be 0. Now we check if PB is low. Low means 0. This 2 equal means compare this with this. So we are comparing it. If it is true, which means if push button is equal low, then take the action whatever is between these two parentheses, so this action will take place. This is exactly the same as before, but here this will occur only if push button is pressed. What it means is if at the beginning somebody pushes the button, it will not take action until 5 seconds passes. After 5 seconds, this event that we have defined as before, 5 seconds is here at the beginning. Until 5 seconds has passed, then we will see this action. Otherwise, this push button, if it is not pressed, the code will not come to execute this. Now, let me run the code. I will just leave it. You see, this is 1 second, 2 seconds, 3 seconds. Now, if I push the push button, you will see the action after 7. Now, if I close the serial monitor and reopen it again, it will reset the time. So I'm pushing the push button, I see 2 seconds, 3 seconds, nothing, 4, and suddenly you see take action. When I remove my hand, it stops. So let me stop it, or maybe disconnect Arduino. So the scrolling stops automatically. So pay attention here, this is 900 milliseconds, 1 second, and as we can see we are at 2 seconds here, 3 seconds, and here 4,995 milliseconds, so it's almost 5 seconds. When it's 5 seconds, it says take action. Action takes place when push button is pressed and the time is more than 5 seconds. And whatever other task that you have will be executed. It will not be interrupted. If you found this tutorial helpful, please thumb up and also click on the subscribe button in the lower corner. I really appreciate it. In this example, we are checking the status of a push button if it has been pressed twice or more. Once it is pushed for the first time, we record the time in the button pushed variable, and then continuously monitor to see if it has been pushed after 5 seconds. For example, at 2, 3 seconds, 4 seconds, if it is pressed, doesn't matter, 4.9 seconds, doesn't matter. As soon as it is pressed after 5 seconds or longer, then we can take an action. Of course, you can make it more complicated, but this is just simple task. So we will check the status of push button if it has been pressed twice or more. And here is a third example. What we do is in this one that we push the button and we make sure the second push occurs after 5 seconds. When it is after 5 seconds, then we take some action. So now at this case, doesn't matter when, maybe after 1 hour somebody pushes the first and then the second. This push can be signal from a sensor from something. I just made this simple, but you can do other tasks. So first we have defined a variable called button push. This is the time when the push button is pressed. What we do is we set it at 0 initially, and then after that, as soon as program starts, it will never be 0. So this is just for our reference. I will show you. Then the rest is the same. And here, after this line, what we check is we check if push button is equal low, which means if push button is pressed, and these two ampersand means and this must be true, both of them. So we check if push button with if button pushed is equal 0, which means it's if it is at the initial state, then we save the current millisecond at the button pushed variable. So now 0 will be replaced with this, and then we say first push at this time, and we print the time that we stored, and that's it. So before, if I go for the second section, remember that when the loop continues next time, if the button is pressed and if the button is not equal 0, this will not be executed. So this will run only once when we save the push button value. Then we check here, the code will check if push button is pressed still and button pushed is bigger than 0, which means it has some value, then we check here. We have a variable called difference. What we do is we get the current millisecond, which is always greater because when the time passes it increases, subtract the button pushed value from it, and we have a difference between the time that was pushed and the current time, and we check if the difference is greater or equal the event. Event is the value that we have here is 5 seconds. Then we take some action which we print. Okay, after 5 seconds this has been pressed. Here in this case I'm not checking if it has been pressed after 6 seconds, 7 seconds, but for us it's important that it has to be pressed after 5 seconds at any time. Of course you can make it very precise. For example, if it is pressed between 5 to 7 seconds, some action should take place, but for simplicity I'm just saying if it is pressed after 5 seconds, this action will take place, and you can put whatever code you want in this area. Let me upload the code. I'm opening the serial monitor. As you can see, the time is running. Absolutely no difference. When I press it, it will be very quick. That you saw that it says button pushed. If I press it, nothing happens. You see now, if it was 5 seconds, let me disconnect Arduino so the screen stops. Let's go and check the time when I pressed it first. These are the milliseconds, 1.6 seconds. So first push at 5019 milliseconds, 5 seconds and 19 milliseconds. So this was when I pushed it. So if you take 5 plus 5, it should be 10,019. After 10,019, it should have effect. Otherwise, a push button should not have any effect. And I pressed it so many times. So this is 7, 8,000, 9,000. You see 10,000 and something. I have not pressed it. At 10,168 milliseconds, I pressed it, and it shows after 5 seconds of the first push. And as long as I kept the button pushed, you will see these values, and after that I release it. Now let's see how we can use the map function of Arduino. It's a function that maps numerical values one to the other when they are linear, and it does the calculation for you. For example, you want to set LED brightness to 65% using analog write. In our previous examples, you saw that we weren't able to just directly write 65% because the value was between 0 to 255. Now let's write 60% for an LED in the format of 0 to 255 format. So we will use 60, 0, 100, 0, 255. Let's see what they are. So 60 is our value that we want, so this is our main value, and because our 60 starts from 0 to 100, it could be, this number could be between 0 to 100, and we want to map it to the value from 0 to 255. So these two are the target, and these are the intended minimum and maximum. So you put the minimum and the maximum and the target minimum and maximum and put your value here. Now we can define a variable integer called brightness and use our function like that. So this says map 60, which is from 0 to 100, to a value which is from 0 to 255. So this does the whole calculation, and the result is stored in a variable called brightness, which is of type integer. Now this brightness will have the value of 153. Without using map, you wouldn't know that 60 is equal to 153 to send it to an LED. So we will use the brightness using analog write, and let's say you want to control pin 3 and put the brightness here, and this will send 153. But you don't worry, you just type here 60 and it will, or 50 or 30, whatever you want, change it, it will be reflected and adjusted accordingly, and it will never go above 255 and will never go below 0. Here is the code for the map example. First we define a pin for LED, pin 3 in this example. The serial monitor is initialized, and in this line we are defining LED pin as an output, pin 3, and here let's say you want the LED to be 60. B refers to brightness, we define it, and here we get the brightness using map, and then B is coming here. This is as if I type 60. So we say 60 should be mapped, which is from 0 to 100 to the value of 0 to 255. So this is mapping it, and the next line we get the brightness and we are printing it using serial print so we can see it, and this line gets LED pin and gets the brightness, so the LED will turn on at 60%. Let me run the code first now, and as you can see this value, and this is a wiring from the lesson where we explained LED and fading. We have used 220 ohm resistor like this, so I don't need to explain it. If you put 60, it will be 153. This line printed this for us. And this is a wiring from the lesson where we explained LED and fading. We have used 220 ohm resistor like this, so I don't need to explain it. And here the 60% has turned the LED like this. So this is now 60%. Now let's change this to 90, for example, and we will see the brightness of this will increase. Now it's 229, so you didn't know to enter 229 here for the pen. And if we go 100, it should be 255. So 255. And let's go 10%. 10% will be 25 point something. Let's go 8%. So this is now 8%, and it means 20. So we are getting percent here, which is from 0 to 100, and we are converting it to, or mapping it to between 0 to 255. And we just say return. Return means return whatever type it is. So return this back. We say if percent is equal or greater than 0, and this ampersand mean and, so this must be true and this portion must be true. So that percent must be equal or smaller than or equal 100. So it must be between 0 and 100, then return. Otherwise do not return anything, or maybe we can say else. Let's put it return 0. So this will return 0 if the condition is not met. If somebody gives minus something or gives 110 or something, it will return 0. Otherwise it will return proper calculation. Now how we use it, we just use like this and pass it to our function. So now I'm deleting this. Remember this calculation, we have this, let's say 60%, and we want to print the calculation. We can do it like this. We can just say B, we pass that B to this function and it will return back a value, and also the same way we can use it in here. So that's our brightness. Now let's upload the code. Open the serial monitor here. Let me upload the code. Pay attention to the LED. So it's 150. 80% and upload the code. Let's see what it returns. It's 204, and let's go 5% and upload. 5% is 12, so it's very dim.